Hello guys, so welcome to another video on Blue Tech Empire Python tutorial. In this video we are going to be looking at the bitwise operator, which is one of Python's basic operators, for those into digital electronics and into binary arithmetics, those who work with embedded systems and the rest, maybe even encryption and those stuffs, encryption algorithm or cryptography. It's very important for you to know how to work with binary numbers, especially stuff like hexadecimal numbers and so forth, because but still yet, even if you don't you may not work with binary bitwise operator. It's still important for you to understand how bitwise operator works, because you may need it one day. So dive directly into the video. Now we're going to work closely with our calculator, because a lot of this stuff on bitwise operator, you need to deal with ones and zeros, so we don't want to stress ourselves a lot. So we're going to work with our calculator. Yeah, and you make sure you put your calculator in programmer mode. You have standard mode, and you can change it to programmer mode so we can work with binary arithmetic. And one other stuff you want to do is you want to change the d word to pure word or whatever. Now, word is just 8 bytes. I think the word byte, all right, byte is 8 bytes. Word is 16 bytes, I think, and so on and so forth. So we're going to work with a byte for the main time. So now I'm going to be showing you now some stuff. So let's start with some common reading. Bitwise operator works on bits and perform bits by bit operations. So bitwise, you have bit by bit operations. So what are bit by bit operations? Now, if you look at a calculator, for example, and you write 1 and you see bitwise here and 1 both equal to, you see it's 1. So like we see, bitwise operator actually work with bits and with bits, with 2 bits. It's actually a binary operator because it has 2 operands. For example, you see 0 and 0. You see it here. Now it's called a binary operator because it has a left hand operand, in this case 0, and it has a right hand operand, in this case we have 0. So we have a few bitwise operators and a few common bitwise operators. These are the and, not, or. And we have also the exclusive or, we have the left shift, and we have the right shift. I think that's what we're going to be working with in this video. So this video might not be long, but so now we have the AND operator, which is usually called the AND gate in electronics. Now the AND operator is very simple. 0 and 0 gives you 0. 0 and 1 gives you 1. Gives you 0. 1 and 0 gives you 0, and 1 and 1 gives you 1. Now let's see through how Python does this. CLS. So we get back into Python, and let's see if we write true. Remember now, in binary mathematics, what's actually happening is 1 usually represents true and 0 represents false. So in our Python, we're going to be using true and false sometimes. So let's say true. It's similar to the logical operators, So let's say true and true. So you see 1 and 1, or let's say 0 and, so AND is Python representation for the AND gates, like, or the AND bitwise operator. That's the AND bitwise operator. In Python, we represent it using this keyword or literal AND, or this construct AND. Yeah, the construct AND. So 0 and 0, it's 0. We know 1 and 0 is 0. If we have 0 and 1, is still 0. And if we have 1 and 1, it's going to give us 1. Same as true. This 0, remember I said it can be false. This 1 can be true. So it's same as 0. False and false is false. True and false is false. If you want to try, you can say true and false. You see it's false. Now 0 and 1 is false. So false and true. We're gonna see false. Now if we have true and true. We have true. Now, these are bitwise operator. Normally, they actually work with numbers. For example, let's look at an example. So here are just some examples. So let's look at the OR operator, the OR bitwise operator first. Now, the OR bitwise operator actually takes two operands too, a left hand and a right hand operand. But if any of the operands are 1, it returns 1. For the AND bitwise operator, if any of the operands are 0, it returns 0. For example, you see 0, 0, 1, at least 1 is 0, it returns 0. 1, 0, it returns 0. 0, 1, it returns 0. If you have 1, 1, then it returns 1. But for the OR operator, that's not the case. In the OR operator, if any of the operands, for example, is 1, so let's start with 0 or 0. Now, we have the straight line, this character. I don't actually, I've forgotten the name of this character. It's used to represent the OR operator. You see OR, the bitwise OR gate or the bitwise OR operator, we use this straight character. So 0 or 0 is 0. 0, once we have a 1 anywhere, it returns 1. 1 or 0, still 1. 1 or 1, still 1. So we can try it with true. Let's try false or false. We have false, false or true. We have true, true or false. We have true because once we have a true, it returns a true. It only returns false if we have false, false. So true or true, it returns true. Now, we have a last operator which we call the NOT. The NOT is a unary binary. It's a unary operator because it has just one operand, and that's the right hand operand. We just say NOT. We use what we call the theta sign. So there is it. We have not 1 is 0. Okay, not 1. Let's see. Mm, not 1 is false. So all right, so let's try the theta not true. All right, so it's considering negate it like a 1. So let's just right, so in this case, we can actually say Python actually considers the theta sign is the not operator, but Python calculates the ones complement, not just the negation. I thought it's actually the negation, but it looked like Python tries to do what we call the ones complement of a number. Ones complement of a number, you reverse the bits and you add 1 to it. So that's why we have something like -2. So it's normally called the ones complement. If you're working with 8 bit numbers, you'll be able to understand. So let's leave the not for now. But you see, if you use if you use not true, you're gonna have false, and if you use not false, we're gonna have true. So let's leave that for now. Let's move. All right, so let's look at some real examples because it's not just about true and false. So now this stuff actually works with real values, you understand? So for example, if we have a value called a equals to ob 11100 and b equals to ob, if you have not watched the video on I think integers where we actually showed how to declare an integer from a binary digits. You can watch our videos on variables where we talked about variable declaration, and where we also talk about Python numbers, you understand? So these are binary numbers. This is the binary. OB is to declare an integer as a binary number. So 1100, we declare another one called 00101. So let's look at the internal representation of A. Let's look at the internal representation of B. So now if you say A and B, it gives you 4. Let's check the binary form of 4. So we see it gives us 100. Now let's check why it's 100. Now it's 100 because, like we said, when you apply a bitwise operator, it works with every bit on the digit or of the number. So for example, in this case where a is equals to 11100, it starts from here. 0 and 1 is 0. Here is a 0. 0 and 0 is 0. Here is a 0. 1 and 1 is 1. Here is the 1. Now every stuff from here and here is 0, so it's ignored. Now I'm going to show you what I mean. 1 1 1 0 0. In this case we have let's open our board. So if we have 1 1 1 0 0, and let's look at the next stuff. The next stuff is B was 0 0 1 0 1. 0 0 1 0 1. All right, so now let's look how the AND operator works. The AND operator, like I told you, it actually works. If you have any 0, it gives you back 0. So in this case we have 0 and 1, it's just going to give us 0. 0 and 0 just going to give us 0. 1 on 1, yes, this is the only one which gives us 1. Every stuff here gives us 0. So you can see if we check the binary equivalent of 0, and normally Python will ignore these two zeros, any leading 0, because they are not important. So Python takes 100 like this. That's why you saw when we said A and B, it returned us 4, and the binary representation of 4 is 100. Here is the stuff here, 100. We can even check it from our calculator by saying let's try it. Let's say A was 28, B was 5. You'll see. So let's say 28. Take note, in decimal, as I write 28, look at the binary representation appearing down here. You see it's 1100. Same like this, 1100. Now you will say 28 bitwise, and now let's look for another. The other value was 5, which is 00101. So you will write 00. Python is gonna ignore, even our calculator ignores it. So we say 101. So sorry, let's write 5. We are in binary representation, so you're gonna write 5. Yes, so 5, you see it's 0101. If you want to write in binary, you need to click here, but we are in decimal. So let's check the answer. It gives us 4, which is 0100. So I just wanted you to see. Let's work with a word. Yeah, so all right, so I just wanted you to see how it works. Let's try another one. So let's say um a let's say a is equal to let's say 0b. I'm declaring it as a binary number 11010011, and b equals to, it's a binary number ob 0. No, let's start with 1, so we don't have 0111010. All right, now let's look for the the equivalent integer. So to find the integer equivalent, we're just gonna say a, it gives us 211, and b is 154. Let's check to be sure. 211, let's be on decimal. You see 211. As you can see, it gives us 1101. All right, okay, let's check 154. Okay, see 154. You see it still gives us 1. Sorry, I wrote 154. All right, 154. All right, 154, it gives us what we are expecting, 100111010. So we are okay. So now we can try to use the AND operator on them. Now let's try to do the calculation ourselves first. Let's try to do the calculation ourselves by saying, let's try to do some rough work here. Maybe let's not consume a lot of time, but not much. So let's try to do some rough work here. We have 11010011, 11010011. So the next part, let's try to check it out. We have the next part is 100110110, 100111010, 1001101. 0. So in this case, we're going to find an, like I told you, once we have one, any 0 and gives us 0. So first one we have 0, here we have 1 1, so it's 1. Here we're going to have 0. Here we have 0. Here we have 1. Here we have 0. Here we have 0. And here we have 1. So our answer is going to be 100. So let's check it out with Python, using Python. And so let's say A and B gives us 146. Let's say bin 146. 146. It gives us, let's see if it gives us what we were expecting. Uh, let's see if it gives us what we were expecting. It gives us 100 100 100 All right, so perfect. Gives us what we were expecting. So there is how you can actually write this stuff. So move to the next part. Let's check now how to use the OR operator. Now, explaining the OR operator is very simple. It's similar to the AND. So let's just use the same example for the OR operator. Now, with the OR operator, anywhere you have a 1, you also have a 1 as the result. So in this case, what will be our result? In this case, we have 1. Here we're going to have 1. Here we're going to have 1. Here we're going to have 0. Here we're going to have 1, 1, 0, 1, 1. Very good. So let's check it. Let's check it out. 11011 Okay. So we're gonna say A or B. You see, it gives us 219. Let us check bin of 219. Sorry, bin. So it gives us 11011. Very good. So you can always still use your calculator if you want. You can write 2C. It must be in decimal. You can write 219, and you see it gives us 11011. So we're good. Or you can choose, you can go to binary and write what you want. If you write any stuff in binary, you see it shows the decimal value. So whatever you want, you can do. So we have looked at the and the or operator. So in Python, here this and sign is used for the and this line, I've forgotten the name of these characters. This one is used for the or operator. So here we have and here we have or. So let's move to the next part. Yes, so what do we have? And or not. Not be, like I told you, is the one complement. The one complement, for example, if you have a value, let's say very easy, but it's quite complicated. If you want, for those doing digital electronics, they'll be able to understand fully. But if you're not into digital electronics, you may not understand the one complement. Let's say, for example, we want to find the one complement of this stuff here, this stuff here. We just need to like take all the values, reverse it. For example, this case, we're gonna have 0, 1. I'm reversing everything here. It's opposite. 1, 1, 0, 0. Here is 1. Here is 0, and here is 1. Now we add 1 to this. Now, if you're not used to binary operators, you don't understand how it works. But if you add 1 to this, you're going to come out with something like this. This is going to be 1 0. So if you cancel this, the final result is going to be 1 0. So here is the ones complement of a value. We can check it out. If we say um let's say we have this value. What's the value? Let me check. B. I think it's B. 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 Let's say bin B. Let's just check. All right, so we have this. Let's see, it's 1011 10011 010 10011 010. All right, so let's find not the ones complement is given by the theta and B. Let's assign it to a value, say C. So let's print C. -1. Let's print bin C. All right, so there bin C gives us you see, check the value. It gives us 10011 010. All right, let's see. All right, so it looks like what I'm doing is actually here. It's actually the two's complement. So I actually calculated the two complements by adding one. So to get back to one's complement, I'm going to wipe this. So I think it was 0, 1, and now just write what was there. I had 0, 1. All right, so what it did is just calculated this. We had 0, and since we have 0 here, like I told you, there's a couple of zeros here, many, infinity. It just converted all those zeros to -1, -1, -1, and so forth. And that's why you can see it has a value negative. You see it has 1, 0, 1, 0, 0, 1, 1, 0. Then it has a bunch of ones here, a bunch of ones. So when you calculate all that, for those who are into binary arithmetic, probably, or electronics, you understand all this stuff. So you just get -155. So there is the calculation for not, but we'll not be doing not quite often. Python is not really used for such low level arithmetic, but we use languages like C for those stuffs, and C will actually calculate the negation properly, not like this. So I just wanted to show you that. Now let's continue from, we have seen the or, we have seen or, we have seen and we have seen not. So here are some of the operators. So and, binary and operator copies a bit to the result if it exists in both operands. So I just want to open here. As we have seen, if we have these two digits, for example, let's say this binary number and this binary number. Remember, it starts from 1 year and this one starts from 1 year. This OB just is just Python way of indicating, or a way of telling Python we actually want a binary number. So let's print A here so we see clearly what's happening. So let's print, let's say bin A, and let's say bin B. Let's just see clearly. Now, if you take, when you use the AND operator, for example, here, you see, like we said, if you have 1 and 1, the result is going to be 1. That's the only time where you have a 1. Once you have 0 amongst any of the bits, you're going to have 0. So that's just what is explaining. While for OR, if we have in the case of OR, if you have any one anywhere in any of the numbers, in case you have a 1 in any of the numbers, the result is going to be 1. So in our case where we had this case here, for example, let me do let me clean it a little bit. So you see, if you are applying the AND operator here, where we have 1, 0, we are going to have 0. Here we're going to have 1. Here with 0, 0. Here we're going to have 1. Here we're going to have 0. Here we're going to have 0. And here we're going to have 1. Once we have a 0 in any of the operands, the result is a 0. Now for the OR, anywhere, once we have a 1 in any of the operands, A or B, for example, we're going to have a 1. So in this case, 1 or 0 is going to be 1. 1 or 1 is 1. 0 or 0, 0. 0 or 1, 1. 1 or 1, 1. 0 or 0, 0. 1 or 0, 0. I mean 1, and 1 or 1, we have 1. So you see, the difference between other operators and binary operators is, or bitwise operators is, bitwise operators actually work with bits by bits. You saw as we declared a variable called A in this case and a variable called B. When you apply the bitwise operator, it works with each bit to find the final result. That's the difference between other operators and the bitwise operators. It actually works with individual bits of the number. You understand? So in this case, let's move to the content. So now we also have the ones complement. We have looked at the ones complement. Then we also have the exclusive OR, XOR. Now XOR is a little bit different from OR, and I'm going to show you the difference. Now XOR is different from OR in that once it sees, if it has either 1 or 0, it will return 1. But in case we have 1 and 1, it returns 0. So it only returns 1 when both bits are not similar to each other. In this case, the XOR is going, here's how we spell XOR. We have it, you can XOR. It's usually called X OR. So we call it the XOR bitwise operator. And in Python, here is how we say XOR. We say A XOR. We use the carried up XOR B. Here is how we say B. So it gives us 73. I'm going to show you how to calculate XOR. Now for XOR, if we have 1 0 1 1 0 0 0 1 1 1 0 0 1 0 1 1. Now anywhere we have a repetition, the XOR is going to return 0. Anywhere there's a difference, the XOR is going to return 1. So in this case, 1 0, we have two different digits. We're gonna 1 1 is gonna return 0. 0 0, yes, of course, they're similar. 0 1 1 is gonna return 1. 1 0 1, I mean 0 1 is going to return 1. 1 1 is return 0 because they are similar. 0 0 is return 0 because they are similar. And 1 0 is going to return 1 because they are not similar. And 1 1 returns 0. So here is the answer for your XOR. We can prove that with the calculator. Let's check it. Now let's be on binary, and let's say C. Okay, so let's say 1 1 0. Sorry, we should say 1 1 0 1 0 0 1 1. Now, and let's use exclusive OR bitwise. It's called XOR. Now let's XOR it with 1 0 0 1 1 0 1 0. Let's find the answer. It gives us you see 1 0 0 1 0 0 1, what we had here. And if you check, it's 73. That's why Python gave us 73 here. So that's what we call the XOR. It actually returns 1 if both operands are not similar. So for example, let's see it here. 0 XOR 0 should return 0 because they're dissimilar. 0 XOR 1 return 1. 1 XOR 0 return 1 because they're dissimilar. Now if you have 1 XOR exclusive OR, is XOR means exclusive OR. It means it's like an OR but exclusive. Both must be dissimilar. So if we have 1 XOR 1, it's going to return 0 because these ones are equal and these ones are equal. So it's good to know. Now if we have OB 1 1 0 0 1 1 exclusive XOR OB, let's say 1 0 0 0 0 1 0. If you look at it, it's going to return 17. And we can all see, if we calculate this, you see it's because here we had 0. Okay, let's now check bin of 17. Let's see. Now you see it's because we had 0 0, it gave us 1. We had 1 1, it gave us 0. We had 0 0, it gave us 0. We had 0 0, it gave us 0. We had 1 0, it gave us 1. So now we have 1 1 0, and Python is going to ignore any leading 0 in front of a binary. For example, if you write OB 0 0 0 1 0 0 0, Python is going to give 8. And if you print bin 8, you're going to see that it has ignored all the leading zeros. So leading zeros don't have any importance in a binary number. So that's what you need to know. So let's move on and see if there's any stuff left for us to cover here. Now we have the left shift and the right shift operator. Now the left shift operator is not, I'm going to use this stuff here. Now let's just see an example. When you say A, for example, let's use literals in this case. Let's use literals in this case. All right, so let's use literals. Now, let's say, okay. Now, let's say, let's use binary literals, for example. In fact, I want to use something which should be very easy for us to see. Let's take, for example, the binary, let's see the binary equivalent of, let's say 33. All right, 33. Now, see how here is what we call the, in fact I'll be reading some. If you shift Let's consider this. The binary left shift operator is given by two carried left signs. For example, if we say 444 left shift, let me say 2, 3. Now you see, let me show you what's happened. Let's say bin 444. Let's see the answer I gave. We left shift by 3. Let's see bin 3, 5, 5. Now take a look at these stuffs. You see, if you left shift, what happens is it adds a 0 behind. If you left shift by 1, it adds 1 0. If you left shift by 2, it adds 2 0. If you left shift by 3, it adds 3 0. So if you see the difference between this binary value and this binary value, it's just that it has what? It has 3 additional zeros because we left shifted by 3. Now let's look at it from the right hand side here. Now take look at this binary value 0011 um 00110010. If you left shift by 2, what happens is two values are going to be added behind and two values are going to disappear because we are moving this way towards the left hand side. So if you see what's happening, you're going to see two values up. Please, if you're not into binary arithmetics or electronics, you may not understand this and you don't need to worry because you may never use this in Python, so you don't need to worry about it. You can actually skip this video and maybe move to the next operator because this sometimes may be intimidating sometimes. So for those in electronics, I know they understand what's going on here. So in this case, for example, you see when you left shift by 2, you have two zeros added. When you left shift by 3, you have 3 0 added and um three items disappear. So you're going to be left with this here 10010 plus three zeros. It happens with 4, where 4 items disappear. It happens with 5, it happens with 6, it happens with 7. So I just want you to see the difference. Now 7, if you do it with 7, you realize everything is gone and you're left with 0. Let's try it here. OB 00110010 left shift by 7. Let's see our reply. All right, it gives us 640 because Python actually added 7 ones in front. Python did this. This is what Python did this. OB 1 2 3 1 added it just in fact it just added zeros behind our value. So Python did this. Our original value was 00110010. So Python just added 10. So Python added 1, 2, 3, 4, 5, 6, 7. That's what Python did. So we see we have 640. But normally, if you're into electronics, you know when you're left shifting or right shifting, you're actually working with the bytes. So you actually lose the highest order bits actually lost. You actually lose the bit at the 8th position. Is it the 7? 1 2 3 4. You lose the bit at the 8th position. That's the highest order bit. You actually lose it. So for those into binary arithmetic or electronics, I know you're actually understanding what's happening. All right, so it's normally we say the least significant bits and the most significant bits here. So usually you always lose as you shift it, the bit is lost. While when you right shift it, like for example this, when you right shift, for example this, when you right shift, you see these values are disappearing while zeros are being added. In this case, for example, when you right shift by 1, you see this 0 disappears and a 0 is added to the front. The most significant bit now becomes 0. Now if you do it with 2 of the most significant bit becomes 0 and the one just before it also becomes 0, but two zeros are going to disappear here. So it works like it works similar to left shift. That's towards the left. Right shift works similar to left shift. But if you shift this 8-bit binary number a specific number of places to the right and replace the new bit from the left with 0, you get, so this is what happens actually. Now, Left shifting is similar to multiplying by or raising something to the power 2. For example, if you say 4 raised to the power 2, it gives you 16. If you say 4 left shift to the power 2 two times, it still gives you 16. So if you say 4, let's see whether it's similar to raised to the power 4, 256. If you say 4 left shift by 4, it gives you 64. All right, it's powers of 2. So if you say 4 left shift by 2 times 4, let's 2 times 2, 4 times 2, 8. If you say 4 left shift by 8, it gives you what of 4 left shift by 6, gives you 256. All right, so normally we say left shift is usually raised to the power 2 to the, okay, it's times 2 raised to the power n, sorry. So for example, if it's the same, like if you say 4 3 is the same as 4 times 2 raised to the power 3, and 2 raised to the power 3 is 8. All right, so it's the same as 4 times 8, which is 32. All right, so if you have 2 right shift 5, it's the same as 2 times 2 raised to the power 5, which is 2 times 32, which is 64. So I think you can understand. 5 left shift to the power 5 is the same as 5 times 2 raised to the power 5, which is 5 times 35. All right, so 5 times 35. Okay. Let's see, let's calculate 2 raised to the power 5. 2, in fact, let me use Python. 2 raised to the power 5, right, 32. So let's say 5 times 32. All right, 160. So it's same as this. While left shift is equivalent to 2 raised to the power n, right shift is the same as 2 divided by 2 raised to the power n. So for example, if you have 1000 right shift 5, is the same as 1000 divided by 2 raised to the power 5. So it's the same as 1000 divided by, I think, 32. No, let's see. All right, yeah, something like that. But the decimal point is usually discarded in this. So let's not dive too much into that, but I just wanted to see there's some similarity between multiplication and left shifts, and there's some similarity between division and right shift. You can read more about that, but I just want to show you Python has both the left shift operator, the right shift operator, the binary not or ones complement, and it also has the exclusive OR operator. It has the OR operator and it has the AND operator. So like we've seen, here are the different operators of Python. We have the AND operator given by AND. We have the OR operator with a straight line. We have the negation, which is usually the tilde sign, which is one's complement, binary one's complement. We also have the left shift and we have the right shift operator. So at this point, I think this is the main thing we need to understand with binary operators when it comes to Python. So here are a few examples where we actually applied binary operators. So in Python, A and B is given by this, A and B, and B and A, C and A. And here, this was a mistake. Normally, it's supposed to be C or E. Here is or E. So here is and, or, and this is not, which is the one's complement. So I just wanted to see those examples. All right, so I guess that's all. So in the next tutorials, we're going to be looking at the Python logical operators. All right, so see you then. Have a nice time.